So I can kind of kick this off. So I'm Olaf Carlson-Wee, the founder and CEO of Polychain Capital. We're one of the early sort of crypto funds launched in 2016, and today among the largest that's investing directly into cryptocurrencies as well as into companies that are building the cryptocurrency industry. And so I'd like to introduce Kevin today, and I'm excited to talk a little bit about Nervos. But Kevin, maybe you can introduce yourself, or maybe most of the folks here are familiar with your background.
Yeah, absolutely. So my name is Kevin Wang. I'm one of the co-founders of Nervos. And so in terms of my background, I came from an engineering background, having done big data in the past, IBM thinking about apps back in the days. And so got into Bitcoin 2013, 2014, around those time, and definitely got hooked, and have a few interest in finance as well as technology, distributed systems, and so on. So when I discovered Bitcoin, was really exciting for me because several things I love and just come together. So anyway, so I'm one of the co-founders of Nervos the early of last year, 2018, and so it's been almost 2 years, but and then happy to share some of that with you guys, in the audience.
Okay, awesome. So I'm going to kick it off with just a few questions, but then as quickly as we can, would love to get to community questions and sort of just answer any questions from the chat. So I think first it's maybe important to set the stage, Kevin, for your thinking about Nervos's design. Like, why did you make the architectural decisions with Nervos that have been made? And so to start, I think it's important to go back to sort of what were the killer features of Bitcoin. And I'm just curious, in your view, what this sort of evolution of your thinking is as far as Bitcoin, Ethereum, and now something like Nervos, and how those architectures have changed, and what's so valuable about the way that Nervos is architected.
Yeah, absolutely. So starting with Bitcoin, this is something I really remember because this is my early days in crypto. Bitcoin's biggest contribution is that you can have a peer-to-peer money that does not depend on any third party or authorities, right? So from an economic point of view, this has never existed in the past. Money as a sort of evolved from gold and silver, and then most modern days to fiat currencies. And they, gold and silver are more like bearable assets, and they don't have counterparty risk. But the modern day finance is all built on trusting the government, trusting financial institutions, and so on. So what Bitcoin does is it invents this new money that really you don't need anybody's permission to have a bank account, and that's a big deal, right? So before Bitcoin, you always need a bank account to have money to perform financial services. So Bitcoin changes that. Anybody can have a address and then can start sending and receiving Bitcoins. So that's from economic side. From technology side, it's also a big deal because peer-to-peer replicated databases or system has never existed. We have internet where it's a peer-to-peer network, and it doesn't have a central governance body, so to speak. There is the internet, but it's ignore that a little bit. That I can send you a message, right, really easily, really cheaply, but you and me are going to both have the message, Whereas, that works for messages or data, but doesn't work for money, right? So what we want is something like, I send you something, then I won't have the money anymore, and you have the money, and everybody in the world will know that. So Bitcoin, started that. So that was really a big deal. And then, going from Bitcoin, I remember the first sort of evolution attempt from Bitcoin. One of the first evolution attempt is Mastercoin. This is where people started to think, well, the peer-to-peer network, the trustless network is really good, but money seems to be a little bit limiting in terms of use cases. So let's add more use cases to it. So Mastercoin, I believe, has somewhere between 10 and 20 different hard-coded use cases. And it's built on the Bitcoin network. But I think the reason that Mastercoin, I was really paying attention to it back then, but I think it didn't work out because Bitcoin's scripting limitation is just so limiting, right? It's difficult
Yeah,
to build
and
on top of it.
Mastercoin attempted to use
So
the
including,
Bitcoin UTXO set to tell which Bitcoin addresses had Mastercoin balances. One of
yes,
the key problems with that architecture and the fragility is that something like SegWit on Bitcoin completely wrecks the Mastercoin system.
yeah,
So you can't really build a substantial large economy, on something like that just can be torn apart by changes in the underlying Bitcoin blockchain.
yeah.
Um,
So by the way,
I also was
Olaf was
following
engineer
Mastercoin.
before.
Yeah, I also was following Mastercoin pretty closely.
Yeah,
Yeah.
right. Yeah. So from there, we just fast forward to Ethereum. I think this is something people mostly familiar. This is where, there's Turing complete scripting, and then running on a virtual machine, right? And then obviously with Turing complete, you can implement any sort of logic that you want. And then Ethereum also surfaced this concept called smart contract, right? So that you can have this sort of decentralized application as a contract that everybody can interact with, um, trustlessly and autonomously, and that's a big deal. So so from Ethereum to Nervos, I was actually think about that. My mental model is this. My mental framework from Bitcoin to Ethereum is from Bitcoin to Ethereum. Obviously, Ethereum took a lot of what Bitcoin had, including POW, the concept of blockchain, consensus and everything. But it has this account model, and then to surface sort of this application, right? Application focused scripting and programming as the smart contract. So and the assets are just internal states of these smart contracts, right? So it's like from Bitcoin you turn right, and then Nervos CKB it's like you turn left, right? So we're not so much application. So the highest level of abstraction, if you will, in Nervos CKB is not applications, it's states or assets. And then just like Bitcoin UTXOs, but we generalize that such that the scripting you give to these generalized UTXOs, language, the scripting capability is Turing complete, just like Ethereum, running the virtual machine and things like that, right? So the structure is still UTXO-like structure, which is basically means bearable assets, right? And then you can spend a asset, you can spend a piece of state, if you will, but you individually would own a piece of asset, right? Instead of in Ethereum, if you want to interact with smart contract, you're basically sending an asset into the smart contract, and then have the contract, sort of in custody of your assets. So that's a little bit subtle, I think, for more like a technical background folks. From technical side, that's you can see like there are two ways to think about this. Basically a distributed ledger is really about who owns what, right? Ownership, and then or account owns state, right? So Ethereum takes a account first approach, right? Takes the person or account as the first level abstract, and then Nervos take the other side, right? Take the state as the first class citizen, if you will, and then and then ownership is inferred just like in Bitcoin, right? So whoever can unlock the, in our case, the cell can be able to, will be the owner of that cell, right? So that's a little bit diagonal to the account model. And then, we're happy to talk about the pros and cons there. If you want to geek out here, but we're happy to kind of, go to other topics as well. But,
I think one thing that I'm particularly interested is the sort of economic design of the Nervos token versus like the base layer token versus, say, Ethereum and the way Bitcoin were designed. Perhaps you could talk a little bit about that.
Yeah, so absolutely. And because our basic data structure is state, you can think about, basic structure of Nervos common knowledge base is basically a collection of state objects. And they will occupy space, global state, right? So the native token of the CKB, the common knowledge base, is called CK bytes. So 1 byte gives the owner the ability to occupy 1 byte of a global state, right? So in other words, if you have 1,000 bytes, and then you can hold 1,000 bytes of global state, and if you occupy 200, then you have 800 left in your wallet, right? And then if you release that state, you have it back. So so the reason we use this model is, well, there are several reasons, right? So first, the CKB is designed to be a store of assets or a store of value, but for multiple types of assets. And then to do that, the economic model have to be designed to match that positioning. So if you think about value storage, this concept of value storage, in Bitcoin, it's a store of value. One of the reasons it can be a store of value is because the value that miners get, the revenue that miners get, they're paid in BTC, right? So in other words, if BTC goes up 100 times, miner income goes up 100 times because they're paid in BTC. And that kind of works out because, right, it's like a city. If your valuable asset in the city increase, then you are able to spend more on the defense. So that will also, protect the city. Whereas just about any other smart contract platform, you don't have this piece of property, right? So to have something similar, you have to almost have like an index fund of all the assets riding on top of the platform, and use a unit of the index fund as the cryptocurrency, right? Otherwise, you don't have the property because asset price can go up and down, and then your miners will not scale their income accordingly, and that's the issue. So in Nervos CKB, obviously we can't really do an index fund, but what we could do is use this sort of this common resource that all assets will need when people hold these assets, which is the storage space, right? The state storage. And that is, in my opinion, the only way you can convert the demand on this multitude of assets into one single asset, and then use that to pay the miners. So, so that's the only way. If you want your security to automatically rise when the city gets wealthy, right? To say, hey, we're going to hire army and prevent loots. Otherwise, I mean, just sooner or later, that something bad will happen.
Yeah, and one way I think about this is that Ethereum successfully grabbed that proof of work insight from Bitcoin. But one of the economic problems with Ethereum is that it's actually the Ether holders that are diluted by inflation in order to support the security of all the tokenized assets built on Ethereum. But those tokenized assets, while they bootstrap on the security provided by Ethereum miners, they are not diluted by new Ethers being issued to miners. So in a sense, tokens in Ethereum are sort of free riders, or more negatively parasitic, perhaps, to Ethereum. And so what the economic model that Ethereum, I don't think, has right today is value accrual to Ether as a result, like as a direct result of smart contracts and tokens being built on top of Ether, on top of Ethereum.
Yeah.
And this is a very big deal to me. It's a very big deal because if we're going to have a blockchain settle every type of asset that we can ever imagine, which is then either synthetically or literally represented in that blockchain, and we're going to have that blockchain settle all of those assets, we can't just rely on speculators to sort of get more interested in speculating on something like a base layer token because there's activity at the developer or secondary asset layer. There needs to be a direct value chain from the secondary asset layer into that base layer token.
Correct.
So Kevin, this to me is one of the critical economic breakthroughs of Nervos, because if Nervos has a lot of tokens and activity built on top of it, the CKB token actually accrues value from that in a very direct way.
Yeah.
And I think that a lot of, I don't think a lot of folks recognize yet how big a deal that is. And that this is the sort of model that today feels like it could scale to real kind of global economic financial settlement. So anyway, I think you said it better than I did, but I really think that's a very important point. So maybe we'll just gotta do one more question, Kevin, before going into the community questions.
Okay.
And that's simple. Why proof of work? It feels like a lot of new projects these days are all trying to navigate the proof of stake or proof of space time design space. Why stick with proof of work mining?
Yeah. We really believe in proof of work because there are several reasons, right? So when you design a layer one protocol, it's our opinion that scalability is not the utmost important design goal that you wanna prioritize for, right? So like you said, Olaf, layer one can be the settlement layer, and then for settlement layer, you don't need to have huge TPS. You just need to be really secure, and then really trusted and really sustainable. So I know a lot of projects go for proof of stake because it could potentially offer a higher TPS, but that's not really the design goal that we had. The other proof of work has a really good property, which is being very objective. And that's again the jargon, but basically means anybody look at the accumulated proof of work can tell that this is the longest chain or not, right? So even I'm joining even in 20 years, somebody spin up a Bitcoin node and then they look at, the Bitcoin blockchain and they can objectively tell which chain is the longest. Whereas proof of stake has this issue of, we call that weak subjectivity. So there is somebody can, potentially collect the private keys from maybe ICO or something like that, and then almost instantly manufacture a chain that's very, very long. Now, this has been spoken a lot of times, and then there definitely, I'm not saying this is not a somewhat solvable issue, and then there are definitely efforts in a lot of different proof of stake projects towards this problem, but it can never be as objective as a pure proof of work blockchain. So that's number one reason. And we believe a layer one, you have to have that objectivity so that anybody can just show up and verify. That's number one. Number two is if you look at proof of stake systems, you tend to have this sort of phenomenon that the set of the current stakeholders control the validator set, right? That's almost by definition, which means if the current validators don't want somebody to join as a new validator, because joining the validator set is a transaction. If it is a transaction, it can be censored by the current validator set, right? So you can make an argument that once a monopoly is established, and then let's say me and 3-4 of my buddies controlling the proof of work blockchain, the validator set, we have enough stake. we can make sure that nobody ever can join as a validator, right? Because we can just censor all the transactions to become validator in the first place. So that's a big issue. So that tend to concentrate power. So that's one aspect. The other aspect, think about proof of stake when, who in the ecosystem would have, accumulate most stake. It tends to be the players with a very strong position in the ecosystem, which is wallets and exchanges. We already see this kind of in EOS, and then out of the 21 validated, how many are exchanges, right? So again, and all these folks know each other, and it's a small circle, and once that monopoly, or it's not monopoly, it's like a multi-poly,
Oligopoly.
but basically
Yeah.
multiple oligopoly. Yeah, there you go. So, but a group of people collecting the blockchain, it's almost well, it's not almost. It is impossible to break it out, right? So now for proof of work, you can argue the same with the mining pools. But on the other hand, we argue that it's always possible to break the current either mining pools or miners concentration, right? Just you can always spend more money. And then even for mining pools, the balance could change. If you look at the mining pool, from Bitcoin early days, I remember, G hash was a big thing at the time. They got like almost 8% of hash power, but now I don't see where they are anymore. Right. So those things can change. And then, the internet broadband technology will develop, and then all of a sudden we'll have a new landscape of who has the access to the best internet and so on and so forth. So it's a very competitive place. And then to keep your so-called monopoly or leadership in the space, you have to keep investing money, right? So it's much, much harder to establish a sort of, oligarchy, if you will, in proof of work as you could in proof of stake. So those are the reasons we feel that proof of work has, if we don't really need the TPS, then proof of work is the way to go.
Okay, great. So with that, maybe we'll go to some community questions. Okay, so I have a couple here that I think were submitted maybe before this recording even started. But of course, in the live feed, in the Zoom chat, you can actually write any questions. And I have a live feed here where I can see what the questions are. So if anyone in the audience has any questions, just feel free to type it into the chat. So first question, how might partners such as Huobi or CMBI use Nervos?
Yeah, so we have partnership with both Huobi and CMBI, and those are really important partnerships for us because both have expertise in the finance space, and then Huobi more so on the digital native side, and then CMBI on the CMBI, for the people who don't know, it's China Merchants Bank International, on the traditional finance side. So both are exploring use cases and opportunities to build applications on the blockchain. So we are actually working very close with Huobi right now to launch the codenamed finance chain, and so to for Huobi, and then this is going to be a regulatory friendly blockchain. So this is one of our other sort of go-to-market strategy is that so the common knowledge, our layer one common knowledge base, we want it to be as open, borderless, permissionless, censorship resistant, and free layer one as possible, like a public infrastructure. But we would like to also support regulatory friendly blockchains, working with or on top of Nervos CKB, common knowledge base. And what we believe is they can bring real world assets into the blockchain space as gateways, being regulator friendly. And then, that's one of the ways we believe that we can have tokenized assets flow, or value, so to speak, flow to the blockchain space. And then the base layer can be a neutral settlement layer of all these different blockchains.
Okay, great. So I'm kind of just looking through the Q&A here. A couple questions are asking generally about interoperability. So how do you think about interoperability of Nervos with sort of other blockchains? Basically, how will Nervos interact with other chains or other ecosystems?
Yeah. So one of the most sort of critical part of being able to interrupt with other blockchains is you share a common set of crypto primitives, right? So this is the reason when you look at Cosmos SDK, and then all the chains built with the Cosmos SDK will be able to interact. And then similarly, all the chains built with substrate on the Polkadot side will be able to interop because they come with the same set of crypto primitives, and then they can interpret each other transactions. So for Nervos CKB, we have this advantage that we call this roll your own crypto primitive, right? So it's possible that if another blockchain are using crypto primitives that you don't have, or it's not natively available on Nervos CKB, anybody can create a cell and then compile that crypto primitive down to the RISC-V instruction set. So we use a low-level virtual machine called RISC-V virtual machine, and this is one of the benefits of that, right? If it's EVM, you cannot do that. It's very, very difficult. But if you have a low-level virtual machine, it's almost like a RISC-V computer simulator, and the toolchain is just very advanced, very good ecosystem support. So for any blockchain, right? As long as they have a C implementation of that crypto primitive, you can just compile down to our native virtual machine. So what that means is you don't need a hard fork. You don't need a core team to do a hard fork for you to use crypto primitives on other blockchains, right? So with this, it's much easier to do cross-chain interops between Nervos CKB with other blockchains, right? And we also we're also going to build our own layer 2 framework, if you will. So we'll have our framework to easily launch new chains, and they will come with the same set of crypto primitives as well, so you can easily interop as well. But I think, especially as a layer 1 that supports sort of future-proof different type of layer 2 technologies, and including other layer 1 blockchains, that sort of roll your own crypto primitive mechanism is going to be very, very powerful.
So another kind of set of questions here is generally thinking about scalability in layer 2. I think, as you said, you're optimizing economic parameters and flexibility at this stage over layer 1 transactions per second, which I think is actually quite wise. But this is a question from a few folks, is what are you thinking about as far as scalability in layer 2 solutions?
Yeah, so we definitely see, there are several directions that the community is taking, and we also following pretty closely. And for the most simple use cases, you have state channels, or even payment channels, which is similar to the Lightning Network on top of Bitcoin. And then because CKB is Turing complete, so implementing something like Lightning would be much more much simpler than Bitcoin. And then you have sort of side chains, and so we again we talk about we're going to have a layer 2 network called Muta, and then we're going to have a sort of turnkey solution, turnkey sidechain solution with Muta, with the sidechain framework that we're building. So basically, anybody can use, we call Axon, but so basically everybody can just click a button and set a few parameters in terms of the assets going to be issued on CKB, and then there is going to be a economic model, there's going to be a governance model, and then there's going to be a sidechain controlled by essentially the stake of the application of the token owners, right? So it's kind of like a DPoS running on top of a POW blockchain, if you will. But that's the sort of thing we feel it's more suitable to have a sidechain solution, like POS or DPS. I mean, layer 2 will be fantastic for those type of solutions. So as long as you can accept the governance model that you trust your token owners, and you probably should trust them anyway, right? Because if you're a decentralized system. So anyway, so that's a sidechain model. And then in terms of permissionless sidechains, in other words, you don't need essentially something like multi-sig to do. We're definitely following the, I think, the optimistic rollups folks are doing a fantastic job, and we think on the zero knowledge proof side, there's going to be a lot of amazing things will happen.
Hey, Kevin, it looks like Olaf ran into a connectivity issue again. Can you access the questions?
Okay.
Cool.
Yeah, I know he has to turn on the VPN. Yeah, I forgot the question. Oh, yeah, it's in the Q&A. Okay, so let me see. Okay, I'm trying to answer some of the more technical questions. Isn't demand for storage space based around each block's capacity rather than total state storage, i.e. there is a specific amount of state storage made available in each block, and demand for CKB will be related to each block's capacity? Rather than total state storage, based around each block's capacity rather than total state. Yeah, it will still be total state storage, right? Because within each block, you can, the user that sends those transactions can either create demand for the total space the state storage, or they can shrink, right, the state storage, or they can keep it the same. It just depends on what type of transactions that they need. Right, so for example, if I do a bunch of transactions, just update my token balance, then there's no change to the state storage demand. Whereas if I'm a new token holder on a specific asset, then that will create new state storage demand. If that makes sense. If I want to store state, I need CK bytes. How is it different from a transaction fee or gas? Thanks. Yeah, so it's quite different, right? So for Bitcoin, for BTC, when you pay a transaction fee, you send a one-time payment to the miners, right? So is Ethereum when you pay gas. On CKB, you occupy CK bytes, right? So you don't really send. Again, let's say I have 1,000 CK bytes, and I need to store state. Let's say I need to use 100 byte state, right? So then I use my spice to store these states, and then after that transaction, I have 900 bytes left that I can send to, I can sell, I can send to exchange, and so on and so forth, right? And anytime I can clear up the state, I can get 100 bytes back, right? So you can see it's very different model, right? So there is also, that we didn't mention before, there's also a model you actually, as you occupy the state, you pay a inflationary based state rent, if that makes sense, right? So basically, we have something called the secondary issuance. Basically, you can think about this as an inflation tax, that if you use your bytes to store state, then there is going to be this inflation tax. If you don't use your bytes to store state, you can deposit your bytes into we call the DAO, right? The Nervos DAO, basically a system smart contract. And so if you do that, you are going to get some, you're going to get essentially a return that's identical to the secondary inflation rate, right? So this way that, you know, if you have to use your bias, then you're basically getting diluted. And then the part of the dilution goes to miners, right? So we call this target inflation, right? So if you think about Ethereum state rent problem, right? So if only, you know, if only we can just extract tax from the people that are using the state automatically with ongoing issuance, right? So that's kind of pointing the direction of the Nervos CKB economic model. Yeah, so we basically use an additional, you know, issuance to inflate everybody, and then we pay back the people that are not using their tokens to store state. Then the, you know, the result is people who do use their token to store state are going to be paying an inflationary tax to the miners. Should I keep going? I think Olaf is still not back yet.
Yeah, I think that we can keep going and just address some more questions that you find relevant, and then we can call it after that.
Okay, so so developing the project in China, I'll pick this question. So how does this impact user trust globally, right? If POW will ensure miners are global, so there isn't a misperception that the coin is somehow run by the Chinese government. I know this is not the case, but there could be trust concerns, right? So I think, you know, again, you mentioned POW. I think with POW, you know, this is, you can be as anonymous as you ever can be, right? With the POW, anybody can spin up a miner and then start, you know, mining the coin and then participate in the consensus process. So, you know, we, you know, most of the core developers are, you know, definitely based in China, but I mean, this is the reason that we are doing, you know, a sale on CoinList, and then, you know, the to target the overall larger global community, and then, you know, we are talking to miners globally, you know, in Europe, in the US, and so on, to participate and then to let them know about the project. And then, you know, this is the reason we have done 5 different iterations. We are running on the 5th mining competition that invite people to come and then to become miners, to get to know the project and get ready to mine the blockchain. We have quite long sort of testnet time. We just want to make sure that everybody, sort of nobody has an information edge, right? Everybody has enough time to come to know the project, and then to, you know, can elect to participate, and then become, you know, become miners, and so that it's not so much concentrated in one region. Okay. Okay, so this is a follow-up question. So a transaction does not create additional state storage is free. We still have something like Ethereum gas, right? So you still have to pay, essentially, you know, similar to gas fees. So this we call cycles, because we use a RISC-V instruction set, which means, you know, we're able to, like, the CPU cycles are essentially, you know, the units computation that we can measure, and it's going to be very very precise, right? So yeah, we do have, we call cycles, and then, you know, there can be cycle costs as well. Okay, so I'm gonna go start from the beginning. I was looking at the question on the back. With so many POS, DPoS projects being launched the last year, plus Ethereum moving to why people W network and what are the benefits? I just want to add that I think it will be interesting to see just pretty much everybody's moving to POS, and then we're launching a new POW sort of, you know, smart contract, you know, equivalent chain. And I think that's, you know, we're pretty unique in that sense, and you know, we're definitely sticking to our decisions. Okay. Currently, what are the risks affecting the Nervos project? In order to develop project in the long term and attract investors, what method do you use to manage minimize negative impact and risks? I mean that, what are the risks and how do you deal with them? Yeah, this is a very broad question. What are the risks affecting? Okay, maybe I'll just slightly, turn this around a little bit because, we still believe that we're in the very early days of the blockchain evolution or the cryptocurrency evolution, if you will. That being early, it definitely has some advantages, but it also means a lot of the stuff we're doing are experimentations, right? So we definitely believe that we're taking on a worthy experimentation for the industry and for the entire space to move forward. But I think for so-called investors or people who like to use our blockchain and use our tokens, and this is a device that I think everybody should know that this is very, very early. It's very, very risky, and then not just us, but pretty much just about any other project. Obviously, we're much earlier than some of the more mature ones, so inherently you're taking a lot higher risk. Um, so how do we manage minimize negative impact risks? I mean, I think just one of the things we want to do is to hire the best developers and then hire the best team and work with the community, and also to reduce the footprint of the founding team in the project over time. That we see is a successful model that pioneered by Ethereum. Obviously, in the early days of the network, I think we are still probably going to be more involved, but we want to have the network run itself, gradually when it's ready. So when the develop 5G network, how will it affect network technology? Would it be the advantage or challenge? So again, today's questions are very technical. So we actually have our consensus mechanism is optimized Nakamoto consensus with the difference with the improvement is that we can automatically adjust the block time or the difficulty with the orphan rate, right? So which means that if we have 5G and the bandwidth globally improves, by the way, it has been like that for the last 20 years. If it continues to improve, then messages are going to be broadcasted faster, and then more messages will be able to be broadcasted at the same time. So in that future, it's going to be advantageous for Nervos CKB because we are going to be automatically adjust the orphan rate. When that happens, orphan rate will drop, and then when orphan rate will drop, then we can produce faster blocks. So which would essentially increase TPS. Okay, explicitly optimizing for SOV censorship resistance. Can you walk through the life cycle of asset on Nervos? Curious about how the economics make it long-term sustainable. Okay, so can you the life cycle of curious how they're gonna make it. Okay, again, very, very technical question, right? So the censorship resistance part of this question comes from our consensus, right? The POW and then the Nakamoto consensus in combined. We also very much prioritize protect the cost of running full nodes. We believe full nodes play a very, very important role in the whole ecosystem. And if you look at the cost of phone operations, right, it's basically bandwidth, CPU, and storage, right? So bandwidth and CPU are somewhat mitigated by Ethereum gas model, right? So you just don't give a very high block gas limit, then you can make sure that, and you can make sure that the blocks don't get too large, and then also the CPUs, sort of the computation throughput does not get too severe. Then it'll be easy to run full nodes. And then what's nobody else is looking at least as far as I know of, is the controlling state storage, right? Because otherwise state storage only go to one direction. So we are, using our economic model, the maximum growth of the state storage is moderated, right? Is by the economic model. So that way, there is a predictable growth path of total state storage that this global state can be. And also, the more state that the blockchain captures, stores, then the more, as I said, state rent is going to be paid to the miners to give them more economic incentive to do so. Again, our state rent is a little bit different from Ethereum. There's no explicit payments, but then they come with the block issuance. Block reward will automatically go to some of the miners. For target inflation. So this is probably too much to go through today, but I recommend that you read our economic paper. It's laid out pretty much in detail there. So what is the role of smart contract in the Nervos ecosystem? What advantage does it have over Ethereum smart contract? Yeah, so both of us are Turing complete, so you could program anything that you want. Now, I would highlight a few advantages. So first of all, the ledger itself is modeled as asset first or state first instead of account first, right? So that has several advantages. First of all, state ownership is very, very, very clear. Even you have, equivalent ERC20 tokens, for Ethereum on the CKB on the Nervos blockchain, the state ownership of each piece of the token is very clear, right? Because each owner will use their own state, their CK byte to store their state, right? So once you have very clear state ownership, then there's the possibility to pay state rent, right? Otherwise, they're just not possible. So this is the typical, the tragedy of commons issue in economics, that when you have people collectively own some resource, then it's very difficult to let people also pay for it, right? So anyway, so that's one advantage. The other advantage is when you do cross-chain stuff, or when you do like layer 2, layer 1 interaction, it's much easier to pass around piece of state than if you were to sort of interact with a smart contract, change its internal state to represent the state change. So just look at, for example, how easy to implement Plasma Cash versus general state Plasma, right? Anyway, that's maybe too technical detail. The other thing is when you have this UTXO-like model, it's much, much easier to have atomic transactions together, because all you can do is just put all of them as inputs and then outputs, and this entire transaction will either pass or fail. Now, this is very different from Ethereum smart contract model, where a contract calls the other contract, calls the other contract, right? You, as the user that initialized the first transaction, you can't really control the end execution of your dependency contracts. But in the more Bitcoin-like UTXO model, you can do that. And also, and maybe I'll just plant a seed here, a lot of the cryptographic stuff that you can do with Bitcoin, you can easily do with Nervos CKB, but expanded that to more general purpose assets. And this is a big deal, right? So we're already aware of several sort of paths that this will allow us to do things that you can't do on Ethereum network. But it's probably too early to talk about those right now. But if you're familiar with the Bitcoin approach, I think you can probably guess what it could be. Okay. What layer 2 solutions? I think we talked about this. Do you expect to work with interoperability platform like Cosmos or for scaling to work with interoperability platform like a Cosmos? Yeah, I mean, you can definitely use chains that made with the Cosmos SDK. When we talk about Cosmos network, it's a little bit, there's hub, there's zones, right? So it's a little bit sort of vague what you mean by Cosmos, right? But you can definitely interact with chains built with Cosmos SDK. with Nervos CKB. Okay, the next one is a Polychain question. I'll leave it to Olaf if he comes back. I think did I answer all the questions? Maybe there are some new ones.
Hey Kevin, we're a little bit over in an hour here. I think that we could wrap up. Where could people
Okay.
find out more about you and Nervos and the entire project?
Yeah, so I'm on Twitter, Kevang, Wang, and Nervos Network is also on Twitter. You can just Google, and we have a Telegram group. Again, just Google Nervos Telegram, you'll see it. And our website is nervos.org. So you can sign up and put an email there. We are doing a sale on CoinList. I think it's coming live pretty soon. I think in fact tomorrow. So you can also go there. It's coinlist.co/nervos.
Awesome. Thank you so much.
Okay. All right. Thanks everybody for coming today.